build the most capable AI model, but if it cannot securely communicate with a client's server room, it holds zero business value. Researchers at MIT analyzed 300 enterprise AI projects. They found that 95% of them produced no measurable impact on the bottom line. The foundation models themselves worked exactly as advertised. The breakdown happened entirely at the deployment layer. Look at this AI project lifecycle. People assume the core task is the local proof of concept, but the model and demo make up only 20. Palantir created this position over a decade ago. Instead of keeping their developers siloed at headquarters, they sent software engineers directly into government agencies and hospitals to build custom workflows on site. Now, frontier AI labs like OpenAI and Anthropic are aggressively adopting this exact playbook to clear their own enterprise roadblocks. A consultant hands a client a slide deck of recommendations. A solutions architect builds a proof of concept on offline data. A forward-deployed engineer embeds on-site, writes live production code directly on the customer's systems, and stays there until the product works. They act as the missing bridge, translating bleeding-edge AI research into survivable software on a very messy construction site. The daily environment of a forward-deployed engineer is inherently hostile to new software. When an AI queries a legacy database, it hits a wall of chaotic data. Initial connections instantly fail. To fix this, engineers use Retrieval Augmented Generation, or RAG, to catch that chaotic data, organize it into neat packets, and feed it smoothly to the agent. Next, the engineer hits the second friction point, the enterprise security team. Systems are tightly locked down. The AI agent must navigate strict authentication hurdles, exchanging OAuth tokens, managing access roles, and securing API keys just to get the data flowing. Standard, locally tested AI code will break immediately when slammed against these live, production-grade security firewalls. Beyond standard security, many industries operate under severe regulatory constraints, like HIPAA in healthcare or SOC 2 compliance. The most difficult deployment environments are air-gapped networks, often found on factory floors or government sites. These networks have zero connection to the outside internet. Standard cloud APIs fail here. Containerization tools like Docker are mandatory, forcing the AI to function alone locally. Engineers also operate within virtual private clouds, or VPCs. Data flows freely inside, but a hard boundary prevents sensitive information from leaking outward. True deployment mastery requires shipping isolated, fully functional code that survives without relying on the open internet. Even if the infrastructure is flawless, the system still has to survive the unpredictable nature of live user interaction. Passing a local test on clean synthetic data tells you almost nothing about how the software will perform when real employees start using it. To manage this unpredictability, forward-deployed engineers rely on evaluation harnesses, commonly called evals, as their primary tool for quality control. This scatter plot illustrates evals. You start with a tight cluster of expected data in the center, but real humans generate wild, unpredictable edge cases. The eval harness provides an objective boundary to corral and categorize these inputs, measuring how well the system handles chaos. Frontier labs like OpenAI weigh an engineer's ability to build these robust evals heavily during their interview process. Engineers guarantee reliability by building resilient systems that gracefully handle an imperfect reality, rather than trying to write mathematically perfect code. To handle this specific set of technical and human challenges, companies are hunting for a profile known as the T-shaped professional. The vertical pillar represents deep technical mastery, fluency in Python, TypeScript, AWS, Docker, and integrating AI frameworks. But they also need the horizontal crossbar, high tolerance for ambiguity, deep customer empathy, and the ability to break massive problems into solvable chunks. This combination creates what the industry calls radical ownership. For these engineers, the job is not done when the code compiles. The job is done when the client sees a measurable business outcome. A standard engineer asks how to code a feature. A forward-deployed engineer asks why the business bottleneck exists in the first place. If you want to transition into this role, you have to stop building toy chatbots on clean data. It proves nothing to hiring managers. Instead, You need to build one comprehensive portfolio project that mimics a real forward-deployed integration loop. Start by scraping genuinely messy public data, wire it to a real Postgres database, and then connect it to an external API that requires complex authentication. This flowchart shows the mandatory final steps. You must wrap the entire system in an evaluation harness to prove it works with real numbers, and then deploy it live inside a Docker container on AWS or Google Cloud. The underlying AI models themselves are rapidly becoming interchangeable commodities. The engineers who command the highest compensation will not be the ones building the foundation models. They will be the ones who can securely, legally, and reliably wire those models into the fabric of the real world.